This is section 5.2, and we talk about one-to-one functions. A function is one-to-one if and only if any two different inputs, x's, correspond to two different outputs. In other words, two x's can't be tied to the same y. And so if you look at that graphically, in this one, a one-to-one function, each x in the domain has one and only one image in the range. This isn't one-to-one because out of this y we have two lines. They're going to two different x's. Now this is not a function because there's two lines coming out of an x. So we learned about the definition of a function that way. So if you were looking to see if this was one-to-one, you want to look here and you see that out of the y, this side over here, this 38 is paired with 55 and 61. So that is not one-to-one. Over here, you want to look and say, is y repeated? Doesn't appear to be repeated, so B would be a one-to-one. Now, just like when we were determining if something was a function, we had a vertical line test. Now we have a horizontal line test to see if that function is one-to-one. So if you draw a vertical line and you hit the function more than one time, it is not one-to-one. So this one's not one-to-one. This one, no matter where we draw a horizontal line, we only hit it once. So that is one-to-one. If something is one-to-one, we can find the inverse of the function. This is where x and y interchange, and the two functions are symmetric with the line y equals x. So here's a graphical picture of that. Here is f of x. Here is its inverse, and they're symmetrical about this line y equals x. They're like mirror images to that. And here is the strategy or the steps for finding an inverse. Number one, if you're given it in the f of x form, write it as y equals. Then you switch x and y. You're going to solve that for y. And in the final step, you replace y with the f inverse notation. So let's look at this. If we had y equals 2x plus 3, we're going to switch x and y. So now we have x equals 2y plus 3. We're going to solve this thing for y, meaning I'll subtract 3, I'll divide by 2. So I have this now. This is what y equals. And then I replace that y with the f inverse notation. Okay? All right, let's go look at our problem set. This assignment should go fairly quickly. Number one, complete the sentence. If every horizontal line intersects the graph at no more than one point, f is, it's one-to-one. That's what would go in the blank. If, on number two, f is a one-to-one function, then f of 1 equals 3, then f inverse of 3 would be, remember, you're just switching x and y, so your value would be 1. If f inverse denotes the inverse of a function f, and then the graphs of f and f inverse are symmetric with respect to the line y equals x. We got that in the notes. 4, if the domain of a one-to-one is 1 to infinity, the range of its inverse is the same thing. They're going to have the same range. Okay? Decide whether the following statement's true or false. If f and g are inverse functions, the domain of f is the same as the range of g. That is true. If 2, -5 is a point on the graph of one-to-one function f, which of the following points is on the graph of f inverse? Okay, f inverse. So you could have -5, 2. That would be the complete switch. And there's that point there. For the function on the right, determine whether the function is one-to-one. Do we have more than one line coming out of the range? Any of the range items? No. So this is one-to-one. Is this one-to-one? No, we have two lines coming out of Kathleen. So that is a no. Is this one 1-to-1? You want to look at each y and see if y is repeated. It is not, so yes, this is 1-to-1. How about this one? Y is not repeated, so that is 1-to-1. Number 11, use the horizontal line test. So you're given this little curve here. I drew the red line. We can see that, yes, it is 1-to-1. Number 12, the graph you're given is a parabola. Draw your horizontal line. No, it is not 1-to-1. 13, the graph of a 1-to-1 function f is given. Draw the graph of the inverse function f inverse. For convenience, as a hint, the graph of y of x is also given. So what you're doing is you're switching these points that you are given, the -2, 0, the 1, 2, and the 2, 5, and you've got it here. You could kind of see that that's what it would be, but you should be able to choose the correct graph. So I think that will get you on 5-1. I mean 5-2. This is really pretty quick and pretty easy.